Josh, if you've been around fluid power for more than a week, you've probably heard the phrase, flow makes it go. The first thing I was taught about hydraulics was that pressure is resistance to flow and pumps only create flow.
It is a bunch of hogwash.
It is.
But instead of complaining that this false concept is still taught, I'll just show you how motion is really created.
Sounds good.
Consider the example in my illustration. I have 3 2-inch diameter cylinders, each butt welded to a 2-inch diameter tube. The first tube is filled with oil, the second tube is filled with ball bearings, and the third tube is filled with a solid steel rod. You'll notice the first 2 cylinders each have 2-inch diameter pistons to contain both the oil and the bearings. Finally, I've asked the credible Hulk, you see what I've done there, Paul?
Very clever.
So I've asked the credible Hulk to push on the left side in hopes of moving our 1,000-pound weights on the right side. I challenge anyone to tell me how any of these examples are functionally different, especially if our X-ray eyes couldn't see inside these tubes. In the first example, credible Hulk pushes on the piston with 1,000 pounds of force, which pushes on the fluid with 1,000 pounds of force, which pushes on the cylinder's piston with 1,000 pounds of force, which pushes on the rod with 1,000 pounds of force, which itself pushes on the 1,000-pound resistance.
Phew, that's a lot of pushing, but as far as I can tell, it was credible Hulk's pushing on the piston which caused the 1,000-pound weight to move?
That's right, Paul. Now, in the second and third examples, when credible Hulk pushes on either the piston or the steel rod, the 1,000-pound weight moves, just like with the first example. The only difference is the fluid rod in the first example and the steel rod in the third example is that the fluid's molecules are free to slide around and move about the inside of the tube. However, force is still transmitted along the same vector as it is pushed against the piston by credible Hulk.
Okay, let me play devil's advocate and argue that, well, maybe the 1,000-pound weight moved because flow was created by the left side piston.
Then I'll ask you to consider the words of someone with even more trustworthiness than credible Hulk, Sir Isaac Newton. His second law of motion states, acceleration is produced when a force acts on a mass. Physical objects can only be set into motion when force is applied to them, and this includes oil molecules. What occurs during flow of hydraulic fluid is that pressure is allowing flow to occur, not the other way around.
So can you give us a practical example to disprove the flow makes it go myth?
Just one?
Sure, just one.
If my pressure compensated hydraulic pump is capable of 100 gallons per minute, with the compensator set at 1,000 psi, how quickly can I move a cylinder load requiring 1,001 psi?
Not very quickly.
That's right, my cylinder won't move a single inch. Even if the pump was capable of 1 billion gallons per minute, there is not a differential of pressure in favor of the pump. No flow will occur. This is because flow is not the generator of motion, but just the time factor applied to the quantity of force being applied.
So pressure always starts at the pump, which is why flow can happen.
If there's no downstream restriction or mass to move, fractional psi is still required to move the fluid, even if it's only air. The only reason a restriction or mass creates pressure is because of Newton's third law, that every action has an equal and opposite reaction. The pump adds force to the fluid, and the pressure rises equally and oppositely to the force until the force from the pump is greater, allowing flow to occur. A hydraulic pump is no different. You can easily translate the examples of the illustration into the operation of a piston pump. Every time a piston in a pump reciprocates, it applies force to the fluid, which is transmitted ultimately to the actuators. A vane or gear is no different, but the geometry is not so simple to visualize as my previous example.
Josh, don't you think it's a little bit narcissistic to create your own physical law, though?
As a member of the fluid power community with an obligation to influence and educate others, I couldn't sit by and watch flow makes it go confuse students and professionals alike. Pressure makes it go. Flow is the rate in which you create pressure. Might not have the same ring, but hopefully the concept of Cosford law is understood regardless.
Sounds good. Thanks for watching, everyone, and check out more of our fluid power videos at www.fluidpowerworld.com.